All right, so we are doing the answer key for the roller coaster problem. In this problem, we've got this design of a roller coaster here, and we are going to generate an energy bar graph for the coaster, earth, and track system modeled in this roller coaster. So the first thing I'm going to do is write out everything in my system, which is the coaster, the earth, and the track. And it tells us that wind resistance and friction are not important. It also tells us that the velocity at the top of hill A is 0 meters per second. So we are going to figure out what the energy transfer is at each of these different positions on the roller coaster. But if you notice, we've got a bar graph to start, and we want to know where the energy is coming from when we get to point A, or in order to get us to point A. And that would be, in roller coasters, a motor. The motor is not necessarily part of the cart on a coaster or the track. It is outside of the system in this scenario, and so we are going to call it energy coming in. I'm going to draw 4 blocks to represent that energy coming in. And since it's a motor, that would be considered chemical energy. So there's no energy in the system when it starts. Now, the motor is going to get it to point A. At point A, we obviously have no kinetic energy, but what we do have is a height above the ground, 40 meters. So to represent 40 meters, I'm going to draw 4 blocks. For part B, it's at the lowest point. It doesn't look like it's on the ground, but if you look at the scaling here, it says that the lowest point of the roller coaster is going to be 0 meters. So there's no gravitational potential energy. And if there's no gravitational potential energy, my 4 blocks of GPE in part A is going to convert to 4 blocks of kinetic energy in part B. Now part C, we've moved up a little bit to 10 meters. That means that I do have a little bit of gravitational potential energy. I'm going to call 1 block representative of 10 meters. And since I have 4 blocks to start, I need to have 4 blocks in part C. So the remainder of my blocks are going to go in kinetic energy. So I have a higher speed at a 10 meter height. I go back to a lower point, D, because it's at 0 meters, it's going to look the same as what I had for B. No gravitational, all kinetic. And then E is going to be the same as what I had for part A because it is at its highest point here. And so it's going to have no kinetic energy and all gravitational potential energy. And you want to make sure that if it starts with 4 blocks, it should have 4 blocks in every single bar graph from A through E. Now we are getting into the calculation. So here we've got a coaster with a mass of 2,000 grams. I'm going to start with the guess method. So my givens are, this is my mass. So M is equal to 2,000 kilograms. How much GPE, that's my unknown, gravitational potential energy, does the coaster have at the top of the hill? Now at the top of the hill, that's very similar to, or it's not similar, it is our energy at A, which means all of the energy is gravitational potential energy, no kinetic energy, so we can just use our gravitational potential energy equation. So that's going to be GPE is equal to mass times gravity times height. If we look up here, the height wasn't given to us in the problem, but it's 40 meters. So I am going to plug in my solving, which is a mass of 2,000 kilograms. Obviously, gravity is 9.8 meters per second squared, as we've always had it. And the height is going to be 40 meters. If you multiply all of that together, you get a total of 784,000 joules. The next problem says how much energy was transferred into the system to get the coaster to point A, and how do you know? Well, we know that energy is conserved, and if energy is conserved, whatever energy was transferred in is the same as the energy at part A, the total energy at part B, C, D, and E. So the energy in is going to equal 784,000 joules due to conservation of energy. How much total energy does the coaster have at point B? Again, that's going to be conservation of energy. If I have 4 blocks at A, I'm going to have 4 blocks at B. So it's also going to be 784,000 joules. I don't know why I can't seem to get that right. How much is kinetic energy and how much is gravitational potential energy at point B? So if you look at the position B, you know that it is all kinetic energy and no gravitational potential energy. So the kinetic energy is going to be 784,000 joules, and the gravitational is going to be 0 joules. In the next problem, it says, how fast is the coaster going at point B? When we talk about speed in terms of energy, we're talking about kinetic energy. And for this problem, we're going to end up using 1/2 mass times velocity squared, because that's our kinetic energy equation. We know our mass is equal to 2,000 kilograms. That's part of our given. And we know that our kinetic energy is equal to 784,000 joules. So we're going to use all of that information to determine our unknown, which is our velocity. All right, let's start plugging in these values. This is our equation, so our substitution is 784,000 joules is equal to 1/2 times 2,000 kilograms times velocity squared. We're going to move the work up here, and I'm going to take my 784,000 joules and divide it by 1,000 kilograms. I just took 1/2 of 2,000. That's equal to velocity squared. And because I don't want velocity squared, I want the square root to get velocity. I'm going to end up with an answer of velocity equal to 28 meters per second. Okay, question 3. How much total energy does the coaster have at point C? As we've stated many times, energy is conserved, so it's going to be the 784,000 joules of energy that we started off with. How much kinetic energy and how much gravitational potential energy is there? So this one is a little bit trickier because we've got some gravitational that has a height of 10 meters, And we do have some kinetic as well. There's some velocity there. We need to add these two together to show that it equals 784,000 joules. So what we're going to do is we're going to solve for gravitational potential energy first. The reason why is because we have enough information. We know the height, we know the mass is 2,000, and we obviously know gravity is equal to 9.8 meters per second squared. So we can do this calculation of gravitational potential energy, mgh. So we're going to take our 2,000 kilograms, multiply it by 9.8 meters per second squared, and we're going to multiply it by our height of 10 meters. That is going to give us a total of 196,000 joules. If this is my gravitational potential energy, my kinetic energy is going to be 784,000 joules minus my gravitational potential energy. So all we have to do is take our total. E total is equal to kinetic energy plus gravitational potential energy. If my total is 784,000 joules, I can solve for kinetic energy by adding 196,000 joules to it, subtract the 196,000 joules. This is a separate problem, just to make sure. I'm going to subtract that to both sides, and I get a kinetic energy of 588,000 joules. So this is my kinetic right here. This is my gravitational. Okay, now we need to find out how fast the coaster is going at point C. We know the total energy. So kinetic energy is equal to 588,000 joules. We still know the mass is 2,000 kilograms. And we also know, and we're solving for the velocity. So I'm using my kinetic energy equation. 1/2 mass times velocity squared. 588,000 joules equals 1/2 2,000 kilograms times velocity squared. We're going to do the same thing. We divide by 1,000 because we know 1/2 of 2,000 is 1,000. This cancels out. We're going to take the square root of both sides because now we've got velocity squared and our velocity squared, our velocity is equal to 24.2 meters per second. So that is our answer here. How much total energy does the coaster have at point D? At point D, it's the same as point A, point B, and point C, 784,000 joules. How much kinetic energy and how much gravitational energy is there? Well, at point D, this is very similar to point B. We have no gravitational potential energy, so all the kinetic energy, all the energy is kinetic. So again, kinetic is going to be 784,000. Gravitational is going to be 0 joules. How fast is the coaster going at point D? Well, the work is going to be exactly the same as what we did at point B. So the speed at point B, where is that, is right here. 28 meters per second. And you can look back at that work if you'd like to. Now we've got total energy at point E. Point E is all kinetic. And, sorry, let's go take that back. All gravitational. And if it's 784,000 joules total, then it's going to be a GPE of 784,000 joules. How fast is the coaster going at point E? Well, the speed is related to kinetic energy. If the kinetic energy is 0, the speed is also 0. Now it says, at what height will the coaster be traveling 17 meters per second? Show your work. So this one's a tricky one. We have height, which is GPE, gravitational potential energy, but we've got speed, which is kinetic energy. This means that we've probably got both of these energy types in our calculation. So if we're solving for height, and we know if we added these two together, it would equal our total energy of 784,000 joules, then let's go ahead and do the calculation for kinetic energy. Kinetic energy, I'm going to do it on the side, is 1/2 mass times velocity squared. So I know that my mass is 2,000. I know that the velocity is 17 meters per second, and I'm going to square that. This ends up coming out to be 289,000 joules. I'm going to plug that in here to 289,000 joules plus gravitational potential energy equals my total of 784,000 joules. If I subtract the 289 to both sides, I get a gravitational potential energy of, and I'm just going to take up space down here. If I continue this down here, I have a GPE of 495,000 joules. This is equal to mass times gravity times height. So I'm just going to plug in our values. Mass is 2,000 kilograms. Gravity is 9.8 meters per second squared. Height is our unknown. If I multiply these two together and divide it to the other side, I end up with 19,600. I'm going to equal that to the left side, multiply that by height, divide the 19,600 to both sides, and I end up with a height of 25.2 meters. And that concludes the problem solving for this very long roller coaster problem. Let me know if you have any questions. We will have a quiz on this next class, so good luck.